Most Python for Android developers have tried this at least once. They call cv2.VideoCapture, expecting a clean working camera feed. It works perfectly on desktop, so naturally they expect the same on Android. But once the APK is built, deployed and launched, the preview stays black. No error, no crash, just nothing. You recheck permissions, reinstall OpenCV, and read through forum after forum. Every post looks the same. Someone struggling to make video capture come alive. This is one of the most persistent myths in the OpenCV world, that cv2.VideoCapture is the way to start camera feeds on Android. It isn't. The reason isn't magic, it's architecture. OpenCV's Video Capture API was designed for C++ layers that connect to camera drivers and media codecs natively. On desktop systems, those backends are available: v4L2, FFmpeg, direct show, but Android is different. Python for Android doesn't compile or expose those backends by default. It runs your code inside an embedded Python runtime without a direct JNI bridge to Android's camera stack. So when OpenCV asks for device index 0, it's basically shouting into the void. There is no capture device registered to the backend. That's why you see no error, just a blank feed. In fact, if you check the OpenCV Android build configuration, the official pre-built binaries show NDK camera no, FFmpeg no. That means video capture has no backend to talk to. So on Android, it's not broken, it's simply unsupported. The fix is to change how you think about frame flow. Instead of forcing OpenCV to grab frames directly, let Kivy or Camera4Kivy handle the device level capture. They already speak Android's camera language. From there, you can intercept each frame as raw RGBA bytes, reshape it into a NumPy array, and pass it directly into OpenCV. That's it. No video capture, no Java bridge, no OpenCV manager dependency. You get clean access to the same image data only through Python's array space. And the result? OpenCV works flawlessly. Rotation, filters, edge detection, saving frames, all directly inside your Kivy app. The reason this works is because you're not depending on OpenCV's broken camera backend. You're using the feed your app already owns. You have effectively replaced cv2.VideoCapture with your own reliable data source. No hidden dependencies, no binary mismatch. When you look at the output, OpenCV processes the frame just as it would on desktop. The difference is you controlled the pipeline. That's the key to making OpenCV work consistently on Android. So, up until now, we have seen OpenCV successfully process frames, but how do those bytes actually get from the Android camera into your Kivy texture in the first place? That's the next layer of the story. Let's look at how the Kivy camera architecture handles this entire flow and why it remains reliable even when other providers fail. If you've been following the Kivy OpenCV Vision Stack series, you already know the 4 core switches that define feed reliability: texture, provider, promotion, and watchdog. The classic Kivy camera only gives you 3 of them. Let's unpack what that means under the hood. Even the classic camera follows the same architectural skeleton. It still uses a provider like Camera Android or Camera G Streamer. Every frame ends up in a texture, which is what you actually see on screen. There's even a bit of promotional logic happening automatically. Kivy quietly checks which providers are available and promotes whichever one reports that it's compatible. The missing piece is the watchdog. If your feed freezes or buffers stall, nothing automatically resets. You'll need to handle that manually. It's a simpler design. Even without a watchdog, you can absolutely use this path with OpenCV. Instead of relying on cv2.VideoCapture, you pull the texture's raw bytes yourself, convert them into a NumPy array, and then feed them to OpenCV. This method works consistently across Android builds, no hidden dependencies, no extra provider required. The trade-off is performance. Because each frame crosses the GPU to CPU boundary, expect lower frame rates. That's the cost of control, but what you gain is stability and full visibility into what's happening with your feed. So when does the classic Kivy camera make sense? Use it when camera for Kivy isn't viable. Maybe you're locked into a specific build pipeline, or you just need a stable path for using OpenCV. It's also great for snapshot-based tasks, logo detection, static measurement, or frame-by-frame verification. It's not the fastest option, but it's reliable, minimal, and surprisingly resilient. So now you've seen it. cv2.VideoCapture isn't the only way to make OpenCV work on Android. A lightweight Kivy camera pipeline can feed OpenCV directly, keeping your vision stack pure Python and device ready. If you would rather skip the trial and error and start with a working Kivy plus OpenCV app that's already tuned for real device image preprocessing, check the resources linked below. They'll get you hands-on faster. Thanks for watching and stay tuned. In the next segment, we'll push this same setup further into vision AI preprocessing, turning stable frames into real-time insight.